The lesson outcome for this video is I can use the distributive property. We will also be discussing combining like terms during this video. The distributive property can be used in a situation as shown right here, A times the quantity B plus C. If a number is being multiplied by a sum, we distribute that number by multiplying it by each part of the factor in parentheses. So, easier to show you than maybe to explain. What we're going to do, and usually you've probably seen, we're going to use an arrow to say we're going to multiply A times B, and then we are going to multiply A times C. When we do so, A times B will be shown like this, and then we need to add the product of A times C. Remember, product means multiplication. So what we have now are two parts. So A times B from this part here, and then if I could change this color here, A times C for this product right here. At this point, we would just multiply A times B, and we would multiply A times C, and keep the addition in between. Let's look at some examples. Our first example, we're multiplying 3 times the sum of x and 6. So we're going to multiply the 3 times x, and when we do so, we get 3 times x, which we just write as 3x. Maybe I'll show the times for this first one. So we would have multiplication in here, plus, then we're going to multiply the 3 times the 6. So 3 times 6. Now when we simplify each term, we get 3 times x, which is 3x. Bring down your plus, and then 3 times 6 is 18. Let's try the next one. Again, we're going to multiply the y that's on the outside to both terms in the parentheses. So the first one is y times y minus y times 12. When we rewrite this, we have to remember that y times y is y squared, not 2y, but y squared. You're multiplying y by itself, and that's squared, minus y times 12. We could leave it as y times 12, but typically we write the coefficient in front, which is the 12, and the y second, 12y. Remember, we cannot combine y squared and y terms. The next example has something a little bit different. You'll notice that we have n plus 5, in parentheses, times n. Remember, in between, right here, in between the n plus 5 and the n, there is a multiplication symbol. Alright, so we are going to do the same thing. We're going to multiply the factor on the outside of the parentheses with each part in the inside of the parentheses. So n times n plus n times 5. Simplifying, n times n is n squared plus n times 5, which is 5n. And our last example. Again, the 9 is on the outside of the parentheses. We need to get that distributed or shared with both items in the parentheses. So 8 times 9. This time it's minus. And x times 9. Now you notice this time I used 8 times 9 and x times 9, unlike over here where I did the n at the beginning. But it doesn't matter because multiplication is commutative. Now to simplify, 8 times 9, 72, minus x times 9, which again I'm going to bring the 9 to the front, 9x. In these four examples, we are distributing a negative number, and this is where many people run into trouble. So be careful when you're distributing a negative. Same process, we're going to multiply the negative 4 times the y. So negative 4 times y. Make sure that looks like a times sign there. Minus the negative 4 times the 2, which also that minus sign is right there, so this is a little tricky. So negative 4 times negative 2. I'm sorry, negative 4 times 2, since we already put this minus sign right here. When we simplify this, we get negative 4 times y, which is negative 4y, minus negative 4 times 2. And negative 4 times 2 is negative 8. You'll notice that we have minus a negative 8, which does turn out to be a positive. So if we wanted to simplify one more time, we get negative 4y plus 8. The next one, x plus 7 times negative 2. We're going to multiply that negative 2. Negative 2 times x plus negative 2 times 7. Negative 2 times x is negative 2x plus negative 2 times 7, which is negative 14. We can leave this as negative 2x plus a negative 14, or realize that adding a negative number can also be written as subtraction. So negative 2x minus 14. Why don't you try the next two on your own and then restart the video and see how you did. Okay, so this first one has a negative outside of the parentheses. Remember that if there's not a number outside of the parentheses, it's actually a 1. We just don't write the coefficient 1. So this has like a little 1 right here. So we are distributing negative 1. So we've got negative 1 times 3y minus negative 1 times 9. Negative 1 times 3y is going to be negative 3y. And if you keep that subtraction sign, then we have negative 1 times 9, which is negative 9. And once again, we can simplify. Negative 3y minusing a negative 9 will make this an addition of 9. And this one over here. We are distributing this entire, let me do this. We are distributing this entire factor of negative 5x to both items in the parentheses. So, start by same process. We're going to write negative 5x times 4 minus, pardon me, negative 5x times x. Negative 5x times 4, multiplication again is commutative, which means that you can do the multiplication in any order. So this entire thing here becomes negative 20x. We multiply the negative 5 times the 4. Minus, now we've got negative 5x times x. Again, just multiplying the x and the x gives you x squared. So what we've got here is negative 5x squared. Simplifying one last time, negative 20x minusing a negative value is going to mean addition of 5x squared. One last thing I want to discuss is combining like terms. Two quick examples. I'm just going to remind you that like terms are any terms that have the same variable part. So if there's more than one x in an expression, they can be combined. If there's more than one x squared term, again, they can be combined. But an x and an x squared would not be like terms. Okay, so let's look at this first one. We have 7x And we have, that's positive because there's no sign out in front, which means it's positive. And we also have positive 2x. And so 7x's and 2x's will give us 9x's when we combine like terms, and then we have minus y. That would be combining like terms, terms that are alike. In the second example, we have 2x squared, again it's positive, and we have another positive 4x squared. Together that makes 6x squareds. And then we've also got here a positive 3 and a negative 1. And these are called constants because they do not have a variable part. They are always like terms. So positive 3 and negative 1, positive 3 minus 1 is plus 2. Oh, bad plus sign. So our final answer would be 6x squared plus 2 for this one. We'll talk more about that tomorrow in class.